Welcome back to the hyperbolic heaping chamber. We are back once again. I feel like I'm in some sort of camp because all we have spent the past 5 days looking at is heaps, or 4 days. I don't even know anymore. My brain is fried. Something about the heap, you know what I think it is? I think I'm very much used to just doing the problems or giving them a chance. And in that respect, LeetCode is actually fun now. So you just kind of trying to figure out the problem, you try and solve it. But sitting here actually figuring out the heap implementation is actually torture. So I think at this point, I don't think the solution is to just quit, but I do think it is time to just look at someone else's implementation. We spent I don't even know how much time on it now, and I think we're just not getting it. So we're probably going to spend this session understanding how the heap works based on some other resources, and then from there we'll just implement that version. And yeah, I'm also second guessing our language choice. I love TypeScript, but at the same time, not having access to data structures is kind of balls. So I'm not really sure what to do there. I can't believe they didn't just, Google, I guess, I don't know. I guess everyone who has a JavaScript engine would have to update it. I'm not seeing why we just can't add some basic data structures. I mean, it's a web language, so I get it, but also, why not just add some? They're adding the new temporal library in the specification, so why not just add some data structures as well while we're at it? So just a little strange. And yeah, implementing them in an interview or just in another setting sounds kind of nutty. So maybe we'll just have to accept our fate and do C++, which sounds worse than implementing the data structures themselves. Maybe we'll use Python, but I'm also not a big fan of Python. I'm not exactly certain why. I feel like the way it reads is just strange, and JavaScript just reads more naturally to me. But Python, I'm pretty sure it's been said Python is like the best interview language, so maybe we'll have to accept our fate. But either ways, it's a sign of the times, and things aren't going well. So that's where we're currently at. I think we're done with the heaps. We're going to look at the implementation today, try and implement it into the problem we were already working on. If we can't, we should be able to figure it out, because we're just going to copy the implementation, and then from there, that'll be that. That being the case, it remains to be seen if we'll do an hour today. I think we're still going to do we're going to do at least 30 minutes, but I don't know if we're going to do an hour. Something about the heap thing is burning me out, so I think, yeah, doing the LeetCode problems regularly now is kind of fun, but the heap stuff kind of not flames. I guess implementing it seems unnecessary. Having to implement it seems a little unnecessary to learn, I guess. Maybe that's the problem, but I really don't want to use any other language than JavaScript or TypeScript, so that is worrisome. We really do be having some thinking to do. Yeah, I really don't want to use any other language than JavaScript. But also, it sounds like torture to use Python. Something's got to give. So maybe we should just switch to Python. That's kind of depressing though. Maybe we should just switch to Python. I don't want to deal with all the syntactical jargon of C++. I feel like that, I hate to say it, but that feels like it could be a waste of time. I use a lot of C++ in college though, but I don't want to deal with all the syntax and semicolon here, pointer there, stuff like that. Or passive I versus passive reference. I really like JavaScript. But you know what? Python lets you use snake case, and maybe that is the solution. Snake case is just a better case. But I feel like having done so much JavaScript, you know, at the end of the day, it's just a tool. So maybe we're gonna switch to Python. Actually, now that I'm thinking about it, the only other reason we might not switch to Python is this might be the only data structure we actually have to implement by hand, because we have access to almost everything else we need to do, like a DFS or BFS. And what are the other categories? If you're going to use a disjoint set or do something like union find, you have to implement it yourself anyway. So maybe it really just is if we don't have access to a heap. Oh no, we don't have access to a deck either, which has given us trouble as well. Which is fine. Yeah, so we'll see how this goes. But that's where we're currently at. We're going to jump into the session, I think. If you're interested in something like this, you should definitely join the Discord, because that is where we are currently at. So that's where we're currently at. If you're interested in the Discord, you should definitely join it. We have hundreds of thousands of people joining every day. So if you're not joining, it could be it's a very large chance that you're going to be missing out on something pretty epic, because we're releasing lots of cheat codes. I also have a secret idea to make a legendary LeetCode trainer that's going to be released to the Discord soon. Actually, soon is a very, very large statement. Maybe in a couple of weeks, but I think it'll be very useful. And yeah, from there, so from there we're going to jump into what we were doing before. So we have a binary tree. We have a heap implementation here from Geeks for Geeks. Right, so we're going to set it for an hour, and we'll see if we get through the whole hour. But yeah, so that's where we're currently at. And yeah, let's see if we can make this make sense. So we had a problem, and I think it was based off of the Explorer card. You're trying to implement heap sort, which is pretty much just the heapify function, which is pretty much just the constructor, which should set up should sort the array in linear time. They're setting this up with HR, which is a pointer to an array of elements in the heap. Capacity, which is the maximum possible size of min heap. Heap size, which is the current number of elements in min heap. So you have capacity, heap size, the current number of elements in the min heap. You only need the capacity to start, interface. So there was a way to get the parent, it's just I minus 1 over 2. I don't know why we couldn't figure that out. And then to extract the root, which is the minimum element, you do extract min, decrease key value of key at index I to new val, whatever that means. Returns the minimum key, delete key. Where's the min heapify function? So this is the function that we actually need to implement. A recursive method to heapify a subtree with the root at given index. This method assumes that the subtrees are already heapified. So we have L is left sub I, R is equal to right sub I, smallest is equal to I. This doesn't make much sense. The smallest index is equal to the index itself that we're at. If L is less than heap size, then HR sub L is less than HR sub I, then smallest is equal to L. Otherwise, smallest is equal Oh, so this is how they fix it. I did if, else if, else. They did it with if. So right, if L is small, if I is smaller, they're making a min heap. So the smallest element should be the top, which means the elements that are children should be greater than it. They're saying if its left child is less than the current element, the smallest equals L, right? But we're checking if it's small, if the right child is less than smallest, which is if the left child was smaller, it'll be the left child. So this catches both if, the left child, the right child, and yeah, it just works really well. If smallest is not equal I, which means we changed it, then we should swap, and then swap I with the smallest child. Which just swaps the literal values. And then we min heapify smallest. It says this method assumes that the subtrees are already heapified. What's the difference? They call min heapify. I don't understand why mine is wrong. For some reason we're doing an iteration over all the elements in the size. Also, we have a min heap thing going on. Oh my god, I think I just figured it out. I'm checking if the left and right childs are valid nodes. I'm not checking that they're in the heap, which we have like in the heap that we haven't. I'm not checking that it's actually in the heap. Just because it's greater than 0 means it exists in the array, but it doesn't mean that it's in the heap. And I think we just have, we don't have to say this dot heap. I think we literally just have size. I forgot where we were at, but we were at time limit exceeded. Maybe the cheat code is how many times they call min heapify. So after extracting the minimum, if that's the case, yeah, then we want to iterate through all elements in the tree and then all elements in the heap, and make sure we try and correct the property for them at least once. This dot left sub index is greater than 0. This dot left less than this dot size, or this dot right sub index and this dot right. Alright, we remove the nonsense we just added. Apparently this was working before. I don't understand. This was just working. Or maybe it never was? Yeah, this is unreadable. This is unreadable nonsense. I have no idea what I'm writing here. Our heapify function is just lost. We had a simple premise and then I don't know what happened. So if we wanted to get the parent of 4, we get 0, 1, 2, 3. Minus 1 would be 2. Divided by 2 would get you index 1, which would be 4's parent. If we want to get 3's parent, we do index 1 minus 0 gives you 0 over 2 gives you 0. So it looks like we're okay. 0, 1, 2, 3, 4 would give you 3. Divided by 2, 1.5. Floor would be 1. Index 1 would be 3, which would indeed be 1's parent. So you definitely can get the parent. The way the heapify works is just if we want to do a min heap, we just need to check if any of our children are smaller than us. If they are, then it means that we should switch with them. You can say const left would be equal to this. Right? And then we'll just say if the value you want to heapify we're starting at would be the index, right? We'd say, okay, this dot nums. Well, first we have to check if the index actually makes sense. We say this dot nums sub left is less than this dot size, and this dot num sub index is greater, or it might just be easier to say this dot num sub left is less than this dot num sub index. If that was the case, we could let our we're basically using the implementation they have, but we'll follow it through. We'd say our smallest index, which starts at our same value, right? We'd say now our smallest index is equal to left. right? Then we could copy this and say the same thing, except with right. And the smallest would be equal to right. Then we could go down here and we can say if index does not equal, or it might be easier to say if smallest does not equal index, we found a value smaller than index. If so, we want to swap places. So we want to save the value of this dot nums sub index, and since we're saving it, we're going to want to replace it with the value of this dot nums sub smallest, and then we'll say this dot nums sub smallest will get the value of temp, and then additionally, right, you want to call this, and I think what we realized earlier is that we want to call this going upwards, at least with the heapify. So it's possible that this upsets our swapped values, our smallest values parent, and so we probably want to call heapify with the new index being smallest. Actually, it doesn't make any sense. We want to call it with the parent index, because smallest would be smallest and index would be swapped, which means index's parent would now be smallest's parent. Even this one gives you 1, 2, 3, 5, 6, 4. Well, I think if we swap, they're heapifying again with smallest. Why would you heapify with smallest? You still get it out of order. Or maybe they're wait a second. Oh, wait. Oh, no, wait. They do the same thing here. It could be that. Oh, my God. There's no way. The reason we kept ending it with 4 out at the... Oh, okay. Never mind. It's still wrong. Yeah, everything I changed was still wrong, so I guess I'm still not understanding. Maybe the solution is not to call... This assumes that the subtrees are sorted. Maybe we should start the heapify at... nums.length minus 1. Oh, wait. What am I doing? This is just the min heap. This is just the heapify function. But the heapify function... Right. This actually... Oh, no. I think I just realized our solution may not have been wrong. This actually does heapify it. And we were getting a similar answer before. This does heapify it. No, it doesn't. Because if this was a min heap... then wouldn't 1 be first? It doesn't make any sense. I returned. I just asked. ChatGPT to help. And I think I know what the problem is. I just realized I'm comparing the actual value that exists at that node rather than the index itself to see if it's valid. Okay. Maybe that doesn't matter at all. Wait, that's true actually. If we only call it for Heapify 0, from the video that we watched, if we call it like this, it shouldn't work because we should have to sort it in reverse. So if we do I is equal to nums dot length minus 1, I is greater than or equal to 0, and do I minus minus. It's still wrong. I don't understand. But this actually, from a heap standpoint, this heapify function this heapify function is technically correct, which means we should be able to do something like this. If we copy after we heapify I, we'll decrease the heap size, and we'll do heap dot num is equal to heap dot nums dot shift do heap dot nums dot push. Okay, we need to. I think we're gonna stop here for today. But I think we're reading a page on writing a heapify function for general heaps. And I think the heaps. I'm looking at the heap sort page now, and the solution or the method is just different. So I think we just need to go back to the drawing board, and we'll read this page and see if we can make some sense.